Okay, welcome back guys for the 7th A-level maths tuition lesson. Today what we're going to be doing is we're going to be covering the circle theorem stuff. So with the circle theorems, the equation of a circle, you have something that looks something similar to this. Okay. Now, the letters A and B, it might be different in your textbook or your teacher might give you something different. It doesn't really matter. They're just some other letter, okay? And what the key point about this is A and B are the center of the circle. I should write equal, actually. Okay, so they're the coordinates for the center of the circle. So if you ever have an equation for a circle that doesn't have these brackets, just as x squared plus y squared, all that means is that the center of the circle is 0, 0. Okay. Now this r squared on the right is just the radius squared. Now that bit is probably fairly self-explanatory. You're probably okay with that. If I gave you an equation of a circle, let's say something like x minus 4 squared plus y plus 3 squared equals 16, you could probably tell me that the center is, all you do is you flip the sign. So instead of minus 4 we're writing 4, instead of 3 we're writing minus 3, and the radius is just equal to the square root of 16, and since it's a length it has to be positive, so we're just going to write 4. Okay, that's fairly simple. However, the main problem, or the main thing with the equations of circles, is you need to actually create the equation of a circle or write it in a different form and then read what the center is and the radius. And then they can also ask you things about tangents to the circle as well. So let's go through that. So this is what it normally gives you in an exam. So the equation says the equation x squared plus y squared minus 2x plus 6y equals 26. And we need to now find the coordinates of the center of the circle and the radius. So I'm not going to write part 1 and part 2 because we can do both of those essentially at the same time. So how do I form an equation that looks like this? Well, all I need to do is use completing the square for x and y separately. So if I bring the x's together, we have x squared minus 2x, and then plus y squared plus 6y equals 26. Okay? And then all we need to do is do completing the square for the x terms and completing the square for y terms. Okay? So for the x terms, we have x plus b over 2, so this is going to be minus 1. And just so you remember, the general equation for completing the square is just that. So x minus 1 squared minus 1 squared, we'll leave that. And then we have the y term, so plus y plus 3 squared minus 3 squared equals 26. So now we have x minus 1 squared minus 1 plus y plus 3 squared minus 9 equals 26. Bring those two terms together, we get x minus 1 squared. I want to bring the x and y's together like this. Minus 1 minus 9 gives me minus 10 equals 26. Plus 10 to both sides, and we finally get the form that we are looking for. Equals 36. So now part 1 says what is the equation of the coordinates of the center of the circle? What we do is we flip the sign of the numbers inside the bracket. So 1 and minus 3. And what is the radius? It will be the square root of 36, which of course is 6. You take the positive value because radius is a length. Okay? So just hopefully you write that down and see if that makes sense. Okay, perfect. So that's kind of the bare bones, the most basic, simple question they can ask you about equations of a circle. Of course, you might think that it is possible that they also just give you an equation that looks like this, and they'll say, what is the radius and what is the coordinates of the circle, center of the circle. But again, generally speaking, this is what they do. So, for question 2, it tells me that the circle C has center 2, 5 and passes through the point 4, 9. Find an equation for C. So, what we need to do here is, in general, we have something that looks like this. Right? Now they give me that the center is 2, 5, so I can write this now as x minus 2 squared. Okay, now I need to work out what r is in order to find the equation of the circle. Now they tell me that it passes through points 4 and 9, so I can sub in that x equals 4 and y equals 9 and get the value for r squared. So we have 4 minus 2 squared plus minus 5 squared equals r squared. 4 minus 2 is 2, squared is 4. 9 minus 5 is 4, squared is 16. So we get 20 equals r squared. So the actual equation of the circle looks like this. Just sub it back into whatever the original was. Done, and that's 3 marks. Pretty quick, so you get a mark for writing this, a mark for the substitution, and a mark for a correct answer. So I'm hoping that makes sense thus far. Question 3, 10 marker, pretty beefy. And this is probably as complex as the questions can get, unless it's the unseen part of the paper. So let's go through it. So part A is exactly what we've just done. We have the center is minus 2, minus 3. So we can actually immediately write that this is x plus 2. And again, passes through the point 1, 8, so we can sub those values in. Perfect. 3 squared is 9. 25. So we have 34 equals squared. And that's going to be it as soon as we sub this all back into our equation. And that'll be 4 marks. If you're wondering why the marks are different to the last question, it's because over the years, the number of marks for each question can change. But this is over like an extended period of time. Part B simply says, show that the point 36 lies on C. So what we can do here is if we sub in x equals 3 and y equals 6, we should get the answer of 34. So let's have a look. So we have 3 plus 2 squared. If it lies on the line, it should equal 34. So we have 3 plus 2 is 5, squared is 25. 6 minus 3 is 3, squared is 9, which does equal 34. So if it does lie on the curve. You can even write equals 34 afterwards. So 34 equals 34. Okay, now part C is where it gets a bit tricky. It's a 5 marker, so it's worth a pretty hefty chunk of change. And what we can do is fairly easily, honestly, once I show you the method, it's going to be quite easy to actually do. Find the equation to the tangent to C at 3, 6. Give your answer in the form ax plus by plus c. So first of all, let's actually look at what's happening here, right? So if I draw a big graph, you don't need to draw this grid every time, but it's useful for when I'm explaining it to you. The center of this is minus 2, 3. So it's going to be like minus 2, 3. That's where your center is. So it looks something like that. Okay? That doesn't matter too much. And The tangent is at 3, 6. So honestly, this isn't the best drawing. So the tangent here, and let's say this point here is 3, 6, okay? Should have drawn the circle a bit bigger, but whatever. We need to find the equation of that line. So normally to find the equation of a line, we need 2 coordinates, okay? And we don't currently have that, okay? But what we do have is this coordinate here, which is, I've already forgotten it, minus 2, 3. Now from your circle theorems, you should remember that the radius meets the tangent at 90 degrees. So in other words, the radius is perpendicular to the tangent. So what we're going to do is find the gradient of the radius, right? So the line joining these 2 points here, right? So we can call that L1, for example. Find that gradient and take the negative reciprocal in order to find what the gradient of the tangent would be. And that way we avoid the need for having 2 coordinates. Okay? So if I write gradient of, actually, let's write on a new line. So again, you don't need to draw that diagram, but hopefully it helps illustrate how you kind of do that. So again, it's the change in y of the change in x. So we have 6 minus 3 over 3 minus minus 2. So that's 3 over 5. Therefore, the gradient of the tangent and hopefully you remember this from your GCSE course, would be minus 1 over that. Or in other words, it's the negative reciprocal, so negative 5 over 3. So now, perfect. 5 over 3, 3 plus c. So 6 is equal to minus 5 over 3 times 3 is just minus 5 plus c. So c must equal 11. So to write the equation in the form x plus by plus c, you have to write y equals minus 5 over 3x plus 11, and then move everything to one side, right? So move everything over, we have y plus. I'm not done though, because if you notice, a, b and c are integers, and this is actually where I see most students lose marks in questions similar to this, but it happens in all kinds of questions. They don't read what a, b and c should be, right? And again, in other questions, they don't read the question fully. If they have to be integers, currently this is a fraction, so I need to times the whole thing by 3. So my actual answer is 3y plus 5x minus 33 equals 0. And that is your actual answer. So be extremely careful with that. Okay? Please excuse me, I have a cough, by the way, a bit. It's from the talking, makes my throat dry. Anyways, 4a, honestly, this is a pretty free question. Find an equation for c. So again, if you remember, we have x minus a squared. So the reason why I actually write out these equations all the time is A, it helps you guys kind of understand what's going on. But whilst revising, I would recommend writing out every equation you use. Because what you don't want to do is be the person right before their exam, even if it's like a mock exam or like an end of unit test, writing out the same equation 1,000 times to try and remember it, and then they forget it anyway. Just write it out as you use it, and you won't need to actually memorize it specifically. The center, so we just flip the signs of that stuff. I know, very specific. It was 49. Sometimes I see students write that 49 is the radius, or likewise when they're subbing it in, they'll say the radius is 7 in this case. Or the radius squared is 7, sorry. Just make sure that you know that this is squared. Okay. Part B, okay, this is fairly interesting. This is, again, it's not a difficult question, although it's worth 6 marks, right? But it's annoying, okay? So the line y equals 3x minus 1 intersect C at 2 points, A and B. So whenever two lines or two curves or whatever, or line and a curve, intersect, it means both equations are true. So what that means is at the same time that this equation of the circle is valid, this is also valid. So what that essentially means is we have a simultaneous equation. Okay? Which means, and now it should make sense why this is 6 marks. It's a quadratic simultaneous equation, which are always worth 6 marks. In fact, sometimes they're worth 5 marks, but you get a mark basically for it being a circle. So the application here gives you a bonus mark. Okay? So all we need to do is sub in y equals 3x minus 1 into the equation, solve for x, you get 2 values of x, sub them both in, get 2 values for y. Very tedious, but again, it should be 3 marks if you're very careful with what you're doing. So let's go ahead. So we have x minus 2 squared plus, then we have 3x minus 1 minus 5 squared equals 49. Let's simplify that first. Okay, now let's expand these brackets. Again, you can expand them into 2 brackets, or you can kind of just do it from hand. X squared minus 4x plus 4. And plus 9x squared minus 36x plus. Yeah, so it'd be minus 18 minus 18. So yeah, good. Then what we want to do is move the 49 over to this side and at the same time gather all the like terms. So x squared plus 9x squared is 10x squared. Minus 4x minus 36x is minus 40x. Then we have plus 4 plus 36. That would give me 40, but then we're subtracting 49, so minus 9. Bit of a killjoy because it means we can't divide through by 10, but it is what it is. And all we're going to do now is the classic. We're going to use the quadratic formula. Factorising this will take too long. So x is either equal to minus b, so minus 40. B squared minus 40. Again, hopefully you remember the quadratic formula by now, but bear in mind you use it a hell of a lot in A-level maths. And it comes up in very surprising areas, but again, if you're not sure, minus b plus minus square root b squared minus 4ac. Perfect, over 2a. Cool. So now we have plus minus, so we have either x equals something. Again, just pull up your calculator and type it exactly as I've typed it, so minus 40. I start with the pluses normally, but it actually doesn't matter. Minus 40 squared minus, whoops, I made a mistake. That would have been disastrous, I would have got the wrong answer. Again, I wouldn't have made that mistake if it's a handheld one. Probably. And you get a monstrous decimal, which is totally fine. Technically speaking, we shouldn't actually round this to significant figures because we won't get accurate answers for that. Annoying question, but is what it is. So we have either, and you can probably guess what the other coordinate is going to be. But we don't guess, we are mathematicians, so let's change that to a minus. Absolutely shocking. Oh, God. Cool. Now to find y, all we need to do is sub that straight into the formula. This is going to be absolutely hideous. But you know, this is the way it is. Minus 1. That's going to make much of a difference, but yeah. Or we have the exact same thing here. I'm actually going to do the right hand one first because it's already saved as my answer button and I'm incredibly lazy. So since it's saved to my answer button, I can just do 3 answer minus 1 and get Jesus. And then we get to enter this whole thing. Yay. Okay. I probably should have guessed that that would be the answer. So your answers can be pretty ugly, but that's okay. Don't worry too much about it. So we have either 20 plus... Well, actually, no. Point A and B. Does it actually give me any information about A and B? It doesn't actually tell us which one would be... which side. As in, which one's going to have the higher x value, which one's going to have the lower one. So we can't actually make it guess. Let's just call that one A and this one B. Again, sometimes what they do is they actually show you a diagram of what this intersection looks like, and they say find the coordinates. In which case, they tell you you'll be able to see which one will have the lower x value. That actually does cost you a mark if you don't get that the right way around. But since they haven't given us any information, we can't be reasonably requested to do this. Perfect. Cool. That was painful. But the answers are correct, so that's all that matters, right? Okay. So with this one, circle C has the equation x squared plus y squared plus 8x minus 4y plus k equals 0, where k is a constant. And it says, given that 1, 5 lies on C, find the value of k. What we have to do here is sub in this coordinate and work out what k is. Okay, so x is 1, so we have 1 squared. And since I'm lazy, let's just do this all on a calculator. So 1 squared is 1 plus, whoops, plus 25 plus 8 minus 20. That'd be 14 plus k equals 0. So you can probably tell that all you'd need to do is flip the sign. So perfect. I don't think that was too bad. Find the coordinates of the centre and the radius C. And then also part 5, yeah, see. So yeah, part C is actually quite interesting in this question, so we'll definitely go through this one. So part B, find the coordinates of the centre and the radius of C. So once again, this is going to be using the classic completing the square. So let's write out the formula. And what we'll do here is rewrite it again, but with the x's all together. Again, remember, it's okay to just rewrite things in a different order, because all of these processes are commutative. Completing the square, we have x plus half of 8 is 4 squared minus 4 squared. Not bad. So x plus 4 squared. And then I'm going to write the y terms. Minus 4 squared gives you minus 16. So minus 2 squared is 4. Minus that, is minus 4. Minus 14 equals 0. Minus 16 minus 4 is minus 20. Minus 14 is minus 34 equals 0. Squared. Perfect. That was pretty good. So B, for the coordinates of the center, all you do is you make it the opposite. So center and the radius just equals the square root of 34, which is a surd, so we don't need to actually write that out. Perfect. Okay, so hopefully that was reasonable. Now for part C, they give us a slightly interesting question. Again, I use the term interesting very weekly. Let's sketch this out first, right? I'll try and draw it pretty big because we're going to need something pretty big. So -4 and 2 is... Now I want to try and draw this relatively large, so... Oh, what a circle. Okay, interesting. I'm great at this. A straight line that passes through the point A is 3, 7 is a tangent to the circle. So, we have some tangent, let's say, going like this. And it passes through the point A, which is 3, 7. We don't know where it touches. And what we need to do is find the length of the line AB. Yeah, so what we're doing, basically, this is point B, this is point A. So try and find the length of it. Okay. First things first, let's draw our radius line. And then we can also draw a line from A to the center. Now that is a big old right angle triangle. Okay, so if I find this length here, this length I can also potentially, I already know what it is. It's the radius, which is square root 34. Then I can just use simple Pythagoras in order to work out what the length AB is. I think that's pretty okay. Let's call this point C. So AC is going to equal to, so it's actually the, sorry, I'm going absolutely crazy here. All we need to do is subtract those two and add them together. Squared plus. Okay, so again all we need to do is take the difference between the coordinates, square them, add them together, and then square root the whole thing, which, let's work it out, 25. Which is 74. Perfect. So now we know that that is also square root 74. So to work out the length AB, again, this is a big right angled triangle because remember the tangent and the radius always meet at right angles to each other. So the length AB is going to just be the square root of AC squared minus BC squared. So 74. I don't know why I was trying to do that in my head when it's fairly obvious. If you square a surd, it just gets rid of the square root sign. So it's square root of 40. Technically, you need to write that in its simplest form, which would be... To be honest, a lot of these questions have become easier since you're allowed to use a calculator in both exams. But yeah. That's it. So that's another style of question that they can ask you. But that's it. That's pretty much it. Right, so in terms of again, this is one of those like unseen questions, which they then turn into a question that you can do every year. But it's unseen the first time it came up. Okay, I think that's pretty good so far. Okay. Perfect. Okay. Again, this is another one of those unseen questions which can be extremely tricky to do. So what we're going to do is, I think it's best to again plot this whole thing out. And this is something that I don't really like about some mark schemes, is that they don't really explain. You know, they explain using numbers rather than actually looking at it. So minus 3, 2, let's say that's over here. Right, that's point D. We have 4 and 1, so it'll be somewhere, like, sorry, 4 and minus 1, yeah. So that's somewhere over there. Again, it doesn't have to be super accurate, really. And f is 1 minus 8, so that'll be here and then all the way down here. And if I were to join this up, right? So I do it with dotted lines at the moment. I actually drew that pretty well, all things considered. It's a right angle triangle, so it says show that it's a right angle triangle, right? So we don't know yet. Whoops. Now if it's a right angle triangle, then what we should know is that Pythagoras' theorem will hold. So DE squared plus EF squared equals DF squared, right? Now if you're wondering why I know to use those ones, essentially you have to actually kind of guess which ones, right? But from my drawing I can see that DF looks to be the hypotenuse, right? If it is a right angle triangle. What you're supposed to do is just work out the lengths of all of these sides, square them, and see if they can add up to make the same number. Okay, so let's go. We need to work out all of those different lengths. So DF squared is just going to be equal to the difference in those values. So the 4 squared is 16. So DF is just equal to the square root of 116. Then let's work out DE. So squared. 4 minus 3 is 7, so it'll be 49. Minus 1 minus 2 is going to give me 9. So we're at 58. And lastly, but certainly not least, we have difference in that. We get 4. 1. Very tedious, right? So we have 9. Again, you can do a lot of this on the calculator now, but obviously if I'm trying to explain it to you, that one isn't going to be very helpful for you. So this thing holds true, right? Because 58 plus 58 would give me 116. And that was perfect. Okay, and for part B, it says, given that, oh god, D, E, and F all lie on a circle, which I'm not going to attempt to draw because it's going to look ridiculous, find the coordinates of the centre. Actually, you know what? Isn't that the best circle you've ever seen? Cool. There is a reason I did that. Okay. So, the angle DEF has to be right angle, right? Because we just worked out the longest side is DF. Now, from your circle theorems, again, so this is why this question was very difficult when it first got released. Okay, because a lot of students don't know their circle theorems. If you take 2 points on the diameter of the circle and try and make an angle, it'll always be at right angles. So because it's a right angle, this length must be the diameter. So we work backwards. Okay? So just to repeat, 2 points on the diameter. If you try and make an angle, it will always be a right angle. Okay? So because this is the case here, then this must be the diameter. So df is diameter So again, it's just working backwards using the using the circle theorems. So if I were to work out the midpoint of that diameter, I should get the center of the circle. So first of all, radius would just equal a half of df. And since we want radius squared for our formula, it'd be 1/4 times 116, so that's 29. Cool. And the center is just going to be the midpoint of this. So we add the coordinates together and divide by 2. 3 plus 1/2. 2 plus minus 8/2. That's minus 2/2, which is minus 1. And 2 plus minus 8 is minus 6/2 is minus 3. So the equation is yeah, so it's actually, the maths isn't that difficult. It's just knowing your circle theorems and knowing like what to do. Can be. Although technically you don't need to know the circle theorem. You could have just kind of guessed that. I just realised I did B and C at the same time. Whoopsie. So part B technically ends there and C is over here. Cool. I can't help being an overachiever. So I think those of you that have done this kind of understand. For the most part. So again, for a question like this, so you know how to do part A. That's fine. For part B, it crosses the y-axis, which means x equals 0. So all you do is sub in x equals 0 and solve. So again, that should be fairly self-explanatory. And for part A, again, AB is the diameter, so we do exactly what we did in the previous question. Find the midpoint, that's the center, and then find the length and half it, that's the radius. We've done the equation of tangents, that was pretty easy. Yeah, I think that's pretty much all we need for today. The equation of circle stuff, again, so what a lot of students tend to do, especially in sixth form, is they get a little bit arrogant. Okay, so they'll see, for example, a completing the square question, a cosine rule question, an equation of a circle question, and they'll be like, it's easy, it's fine, I'll do it. But I guarantee you haven't done the hardest questions of those 3 topics. Okay, because those tend to come up in exam papers and they tend to be unknown. So what you need to make sure you're doing is practicing these questions, even if you find them easy, okay? Because again, it comes up all the time, right? How many of you would have known to do this for question 6, even if you find equations of circles easy? Well, you need to really understand circles and the maths behind them in order to do it, okay? And draw out diagrams and things like that. So if you find something easy, find the hardest possible questions. Generally speaking, online, a lot of these questions are ordered in terms of difficulty. There's no reason why you can't just open up a bunch of past papers and do all the questions in it. All of the, in this case, equation of a circle questions. But again, if you do get kind of stuck on what you're doing, then you can always kind of email me at the description, and then I'll be able to like solve it for you. Or again, you can message me if you've joined the live stream lesson. But other than that, I think we're pretty good for today. We've done the vast majority of the questions, and the other questions are basically just repeats of what we're doing. It's not too tricky, you just need to use completing the square and then be very careful with working it out. So I'll leave it there, and I hope you all have a wonderful evening.